So here's a network flow problem from the 2018 Cambridge Standard 2 text. Water pipes of different capacities are connected to two water sources and two sinks, source 1 and source 2 and sink 1 and sink 2. Network of water pipes is shown in the diagram below. The numbers on the edges represent the capacities in kilolitres per minute of the pipes. Find the maximum flow in kilolitres per minute to each of the sinks in this network. Now, if we look at a slightly larger version of the diagram, and we first of all consider this top row here, we can see that the constraining edge is going to be this one with the 6 on it. So what we do is we cross out the 6 and we put it over here because we're saying, look, we've got a maximum of 6, but we definitely know we're going to get 6. And then we take away 6 from all of the other edges that lead into and along that path there. So 6 minus 6 is 0. What that means is there's no extra capacity in that edge. 13 minus 6 is 7. And that means, of course, we have got excess capacity on that edge, and we might use that later. All right, now let's consider this set here, and we really should have put vertices letters on there that would make it easier to explain. We've got 15, we've got a 12, and we've got a 2. So clearly the critical edge there is going to be this 2. So what we do, whoops, I want that still, is we get rid of this 2. Here we go, look, okay, we've got that 2, we add it up in there. We say 2 minus 2 is 0, so that edge there is maxed out now. 12 minus 2 is 10. 15 minus 2 is 13. And are there any other ways that we can get into sink 1? Well, no, there's really only those 2 edges. So what we know about sink 1 is that our flow is 6 plus 2 is going to be 8 kilolitres per minute, and that's it, we're done for sink 1. All right, let's have a conversation about sink 2. I'm going to change colours up in here, we'll do pink. Okay, first of all, I'm going to take this rather sort of indirect route through the top there, if you will, through the middle and the top. So let's see, we've got what's going to be our weakest link up in here? Well, clearly it's going to be this 7 here. See that? So we write sink 2 over here. We're going to get a 7. So we get rid of that. 7 minus 7 is 0. 14 minus 7 is 7, which means we've got more capacity still on that edge. This edge is having a bit of an interesting life. 10 minus 7 is 3. 9 minus 7 is 2. I almost made that a 7. And 14 minus 7 is 7 again. I hope my numbers are correct. Have a bit of a look. Now let's look at this sort of middle option here. Okay, can we do something with that? Well, we can. We've got 7 and a 3 and a 7. So clearly maximum flow through that path is going to be 3. So we write our 3 up in here. 3 minus 3 is 0. We're done. We're maxed out on that edge. 7 minus 3, well, this guy still has capacity. You've got 4, and 7 minus 3 is 4 again. But we're not done. So we've got this one here. Okay, 8 and 6. So clearly it's going to be all about the 6. So I'm going to write that 6 up in there. I'm going to get rid of that. Going to do 6 minus 6 is 0. 8 minus 6 is 2. Do we have any other options? All right, let's think about this. So can we go, for example, could we do that? No, we can't, because the last edge there is completely tanked. Can't do anything with that. But I want you to notice we've still got capacity on this edge. We've got capacity on this edge. And where else have we got capacity? Got capacity on this edge. We can't do anything there. There's nothing going on there, right? But we've got capacity on this edge from source 1. Huh. Can we push something down there? Well, yeah. We could actually push 13 units along there, which is nice, but we're not going to use them all because we only get 10 down in there. We only get 2 down in there. So even though we could take 4, clearly we're only going to get 2. So we'll just get rid of some of that. And I'm going to give this its own special color, even though it is going to go in sink 2, just so that you can see I'm coming from a different source. I'm going to write my 2 up in here. I'm going to add all that up. I'm pretty sure we're done now. We'll just check. 13 minus 2 is 11. 3 minus 2, you can see what I was saying about that edge having an interesting life, is only 1. 2 minus 2 is now 0. So we are tanked on that edge. 4 minus 2 is 2, but that's it. There are no more other ways into sink 2. 7 and 3 is 10. 6 and 2 is 18 kilolitres per minute. And that is how much we can get into sink 2.